Ayush, can you tell me the A part?
Yeah, one second. Yeah, for 3A1, I wrote internal energy is the energy which is contained within any thermodynamic system and is the sum of the kinetic and potential energy associated with the molecules' movement
Perfect.
in a system.
Mm-hmm. And what is
And
thermal?
then for thermal energy, I wrote it is the energy contained within a system which is responsible for the system's temperature.
Okay. Okay. So, Samuel, what are your answers for both?
So for internal energy, I just wrote it is the sum total of potential energy and total kinetic energy of the substance.
Correct. So, that is the gist of what I wanted to hear, which Ayush also just said. Potential energy plus kinetic energy. Correct. Thermal?
And for thermal, I wrote it is the measure of, I'm not sure whether it is average kinetic energy or total kinetic energy, but that of the substance.
Could you repeat again?
Like I wrote thermal energy is the measure of total kinetic energy of the substance, but I think it's not total, it is average.
Yes, it is actually average, but in your marking scheme, they have written it like this. So, thermal energy, first of all, it's a measure of the temperature of the system, and then this thermal energy relates the transfer of energy between different bodies as a result of temperature difference. So, let me just write the whole thing. Relates to transfer of energy between different bodies as a result of temperature difference. Temperature difference between them. So the temperature difference is the key to this. So they have given marks only if you put temperature difference. So remember this carefully, the definition of thermal energy.
Yes, sir.
Alright, B part. Ayush, tell me your answers to B.
So for B1, I got 28,350 joules.
28,000, yeah, correct.
And
And
then for B2, I got 7650 joules.
7, 650,
7,000, yeah,
650 joules. That's
7,650.
correct. Samal, did you get these answers?
So I actually didn't get the B1, but for B2, they have asked us to find the power, right?
Yes, you have to find the
So for
power.
power, I got 63.8 watts.
Okay, just a second. Oh, Ayush, yes. So if you check the energy, so the answer, Ayush, which you told me, that was the energy. They are asking the rate, which is the power.
Oh, okay.
Anyways, let's go step by step. Part one, Somil, you were not able to solve this. First B1.
Like when he said 28,350, then I saw that it is one of the values that I had got for second part.
Okay. Okay. So
But yeah, can you still explain that? I didn't get
yes.
it.
So we have to find the change in the internal energy of the water. So first you have to figure out which energy is responsible for this change. There is only one energy, which is the heat energy. So the delta U will be equal to Q, and that is mc delta T. So initially you had water 0.25 kgs at a temperature of 18 degrees Celsius. The heater is switched on for 120 seconds, the 300 watts, and later the temperature increases from 18 to 45 degrees Celsius. The specific heat capacity is given. So that's it. The mass is given, the C is given, the delta T is also given. So the mass is 0.25. Multiply that by the specific heat, which is 4.8 into 10 to the power 3 into delta T, that will be 45 minus 18. So if you solve for this, you
Yes,
will
sir.
get
28,350.
28350, or we can write 2.83 into 10 to the power 4 joules. So this is the part 1's answer. So Ayush, this was correct. Now part 2 is the rate
I
at which,
just I just solved B2. Is it 64 watts?
yes, it is 64 watts.
Okay.
Good. So Samal, did
I
you get
forgot the
64?
last one.
Yes, sir.
Did you get 64 as the answer to B2?
Yes, sir. 63.8.
Yes, so 64, yes, approximately 64 watts is the answer to part 2. Could you explain, Samal, how did you get that?
So they have asked for the rate of heat loss to the surrounding.
Mm-hmm.
So for that, firstly, I calculated the total power that is supplied by the heater, which will be the power into time, which is
Correct.
300 into 120.
Yes.
And then, like for the part one, the value that we found, that is 28,350, which is
Mm-hmm.
the actual value of heat that it received.
Correct.
So then the heat lost will be the 36,000 minus the answer for part one divided by 120, which
Correct.
is
So
64 watts.
we solve for that. No, if you subtract these two values, you will get 7650.
Then divide by 120.
Yes, so then you have to divide that by 120 to get the power, which is approximately 64 watts. Alright, part C. Ayush, tell me your answers.
So I'm just like resolving this because I need like answer for B2, right? In
Okay,
this.
so take a
So I'll
moment.
just
Okay,
resolve it once.
okay, so please solve that. And in the meantime, Samal, tell me your answer.
For C1, I got 2.36 into 10 power 6 joule per kilogram.
Good. And second,
Yeah, for the second one, I wrote that the potential energy of the water molecules increases when it is boiled, but the kinetic energy remains constant. Hence, the temperature
temperature
will
remains
also be
constant.
constant.
Yes, good. That is enough. That is a good explanation for this. Ayush, you let me know whenever you finish.
Yeah. So like I'm getting stuck in this one.
Okay, so let me explain.
Like we're supposed to use Q by M equals L, right?
Yes, so since in this case the water is boiling, so you will have to use ml formula.
Yeah.
So okay, let me solve this. So q is equal to ml. Since we are supposed to find l, m you already know, which means q is what we need to solve this question, isn't it?
So I got Q as 1.18 into 10 to the power 5.
So that's fine. So that's it. The most of the hard work you have done, that is correct. So q is 1.18 into 10 to the power 5. All you need to do is just divide that by the mass. But this mass is the mass which is actually boiled. So initially the
Yeah. So
mass of water was,
0.25 minus 0.20, right?
yes, correct. So this will be 0.05. So
Yeah.
1.18 into 10 to the power 5, divide that by this value, 0.05. You should get 2.4 into 10 to the power 6 joules per
Yeah.
kg.
Yeah. 236 and then 4 zeros. Yeah.
All right. And for the part 2, it we the same explanation
Oh,
goes that the, okay, what
Yeah. I
happened?
wrote that all the thermal energy gets used up in breaking the bonds, therefore doesn't get used in increasing the kinetic
But you
energy.
have to write the potential energy aspect as well. It breaks the bond, yes, which in turn increases the potential energy such that the kinetic energy remains constant,
Okay.
right? And kinetic energy is a measure of the temperature, and therefore the temperature is also constant. So step by
Yeah.
step you have to write down the whole thing, starting from the breaking the bonds. Okay, so let me know when you are done writing.
Answer.
Okay, so we are left with two more questions, the non-MCQs.
sir.
Yes.
So for the C1, I actually got disconnected for a second, so I just wanted to confirm one thing.
Okay, just a second. C1. Okay, yes. Tell me.
So I just wanted to confirm my method. So I did 300 minus 64 whole into 500 is equal to m into L, and m they have given it as
Samuel, just one moment.
0.05.
Please repeat this time again.
So I wrote 300 minus 64 whole into 500
Mhm.
is equal to 0.05 into L. Is that the correct formula to use?
Yes, absolutely. That is what you need to do,
Okay.
because see the power of that. What is that? It is a immersion heater. That is a
Yeah, power is
300.
300 and then power loss is 64, which we just found
Yes.
earlier.
So let me just do it step by step. So for
Just
five.
use Q equals PT, right? And
Uh,
then so 500 into 300 whole minus
yes.
500 into
So
64.
this 300 into 500 is the input energy, and what energy goes to the surroundings is 64, which was
500
the
into 64.
64 was the answer to the previous part. If I multiply that by 500, this will be the total energy which is responsible for the boiling, and this is equal to m into L, right? So this is what you had done, Sommer, right?
Yes, and for mass it is 0.25 minus zero point 0.2, if I'm not wrong.
Yes, which is 0.05. All right. So
Yes.
okay, Ayush, is it clear?
Yes, sir.
Okay. All right. Now, Sommer, question 4, part A. Tell me, how have you explained this?
So I actually couldn't explain this one in words. I just uh, like I just mentioned its value and its unit.
Okay, so basically what you have okay, Ayush, what did you do for this?
I just wrote that it represents the gas constant and has the value of 8.31
Hmm.
joules per inverse Kelvin
Okay,
inverse.
that is fine, but that will not give you the full marks. So you have to start with the ideal gas equation, PV is equal to nRT, and write R as PV divided by NT. Then we have to write this is a constant irrespective of the values of pressure, volume, temperature, number of moles. And then we write that this is equal to 8.314 joules per Kelvin, right? So this is how the R is defined.
So I only wrote this much. So is that the only thing, or do we have to say something in words as well?
No, so in the marking scheme only this much is written, so this is fine. Anyways, this was just a one mark part for part A. Okay. Okay, part B. Ayush, tell me your answer.
So for question 4, I was only able to write for A. I didn't get the rest.
So you didn't solve question 4.
I mean, yeah, technically, no, I didn't understand.
Okay, you didn't understand, or you did not attempt.
Yeah, like I tried to attempt it, but I wasn't being able to do it. So
Okay.
I moved on to question 4.
Okay, fair enough. Somil, did you solve B part?
Yes, I've solved everything after this.
What is your answer?
I got 390.6 Kelvin.
Yes, so that is the correct answer. So Ayush, please read the question. We have to find the temperature when the number of moles are given, volume is given, and pressure is given. See, all of the parameters are given to you. Can't we find the number of moles, which will be
Yeah,
PV by RT? So solve for this and tell me what is the number of. Okay, just a second.
yeah.
We have to find temperature, not number of moles. So tell me what will be the temperature value.
So 390.85.
Yes, so approximately 390 kelvins is the answer to
So
this.
I got my mistake for this.
What was it?
I tried to convert the number of moles into number of atoms.
That is not needed, because in the ideal gas equation you have N, which is the moles,
Yeah,
not atoms.
I converted it into atoms, and that's why like my number was very big.
Okay, no, but that is not needed, so please be careful. Alright,
Yeah. Okay.
so C part. Somil, tell me your answer.
For part C, I got 1270 joules.
Perfect, absolutely correct answer, 1270 joules. Ayush, I think we have not solved this either, right?
Yeah.
Okay, so read the question. So you have a gas in B kept in the cylinder. It is heated at constant pressure until the volume occupied by the gas it increases from the original volume to 3.6 into 10 to the power minus 3, and the original volume was 1.4 into 10 to the power minus 3 in part B. So increase in the internal energy is given to you 760 joules. So we have to find the thermal energy given to the gas. Could you figure out a formula, Ayush? What is used to find this?
I mean, in this case, because they've mentioned internal energy, so it should be like the sum of Ke and Pe.
So we have to use the first law of thermodynamics for this. See that Q only has two formulae for IB physics. Either you use mc delta T or ml, or we use the first law of thermodynamics, which is delta U plus the work done. This
Yeah.
is nothing but your energy conservation principle. So delta U is given to you, which is 760. Now work is what we need to find. Do you remember the formula for work, Ayush?
Like in this context, I'm not very
So
sure.
see, if the pressure is constant, then the work done by the gas is given by this formula, P into delta V, where P is the pressure, constant pressure, and that is given to you in part B as 2.32 into 10 to the power 5 pascals. Now delta V, you can find that out from, this is the final volume and this was your original volume. So if you subtract these two, you will get the delta V as well. So solve the whole thing and tell me what will be the value of Q.
Yeah. I'm getting it as 1271.4.
Perfect. So the P delta V should approximately give you a value 510. So if I add 760 and 510, you will get 1270 joules as the answer to this question, the heat energy, right? So Ayush, you have to remember, whenever heat energy is being asked, either you use mc delta T ml, or we use the first law of thermodynamics, which is delta U plus work done, right?
Yes. Yeah.
So please do remember this. Now moving on, part D. Somil, what's your answer?
So for which one?
Last part, D.
Okay, D. For D, I wrote that when the volume is rapidly reduced by pushing the piston in, the molecules inside will gain kinetic energy suddenly,
Mhm.
and due to the sudden movement, the kinetic energy of the molecules increases, hence the temperature also increases, and it leads to an adiabatic change.
Okay, before that you have to explain what does adiabatic mean. So can you recall what is adiabatic process?
Yeah, and like from what I remember in adiabatic process, the delta Q remains zero.
Yes, so the heat transfer does not take place. So Q is equal to 0, so no heat transfer. So first you have to write down the definition of adiabatic process, no heat transfer. Now then you have to explain why the heat transfer is not taking place when the this compression is rapid. So could you tell me the reason?
So like here, the heat energy is not being directly supplied, but it's due to that sudden movement of the piston. So technically, there's no heat energy being provided or lost.
Okay, so you're close, but not the exact thing. see you have to focus on the keywords, which is rapidly in this case. So there has to be some connection with the time to the heat transfer. So rapidly means the time is very small. So the way to write this is, since the compression is rapid, which means the time taken is very small, so we write insufficient time for energy transfer. So although energy transfer will take place, but that requires some sort of time. In this case, the compression is very rapid, so the time is very less. So the process does not have sufficient time for energy transfer to take place. Hence, it is sort of like the adiabatic process where no heat transfer takes place. Are you getting it?
So, but if a lot of energy is being provided in a very small amount of time, then like I didn't understand how it relates to this.
No. So, like for example, a very large energy in a small span of time is only practically true when you are focusing on the nuclear fission and fusion parts. So in the normal thermodynamics, when your time taken is very small, it's like saying 0.0001 seconds. So the heat transfer, whatever is happening, it it does not have too much time to either go into or outside the system. For the heat transfer to take place, you have to give some sort of time, at least 0.5 seconds or 1 seconds.
Okay, so like the answer that I wrote, is that correct or?
Could you repeat it again? Let's see.
Yeah, I said that when the piston is rapidly pushed inside, the volume also gets rapidly reduced, and this leads to the molecules inside gaining kinetic energy, which
Mhm.
increases their temperature, and hence this leads to an adiabatic change.
But you haven't connected that with the definition of the adiabatic. See, in the marking scheme, especially I saw that today. See, first they have described what does adiabatic mean, which is no heat transfer. Then you go back to your question, connect the keyword rapid with this no heat transfer. So how do you do that? Since the time taken is very small, so this time is extremely small for any sort of energy transfer to take place.
So, but what about the part of the definition where it says that adiabatic change also leads to an increase in temperature? So, like that is the aspect that I explained.
Okay, so you have to start by, all right, so that's like the not the fundamental definition of adiabatic. So the fundamental definition is this: q is equal to 0. What you are saying is a consequence of this no heat transfer. Okay, so let me go through that again. So if I say q is equal to delta u plus work done, if q is equal to 0, now what you are saying, does the temperature increase?
Yeah, like in an adiabatic change, it's very close to the isothermal curve, but here the temperature increases.
Okay, so could you explain why the temperature is increasing?
So the piston is pushed inside rapidly. So that piston gives the molecules kinetic energy.
Mhm.
So since the kinetic energy of the molecules has increased,
Mhm.
the temperature will also increase, right?
Okay, that way.
Yeah.
All right. So, okay, although yes, Saumil, that is the correct answer, but I doubt they will give you full marks for this because you have to connect the fundamental definition of adiabatic, which is q is equal to 0. What you are focusing on is the subsequent definition of adiabatic. You may or may not get the full marks, so that's why I recommend to stick to the fundamental thing.
Yeah, okay, I understood this part. But so when we had learned it in school,
Mm-hmm.
I remember that our teacher had specifically told us that when they have said that the volume is being reduced, like not very rapidly, but at a uh, like a slow pace, at that time the temperature will remain constant because there's no substantial kinetic energy being given to the molecules. But when they are being compressed rapidly, then the temperature increases and that factor comes in.
Yes, that is true. That is correct. So, do you have any doubts in that?
No, like I was just saying that that's what I was able to relate to this, so I had written
Okay,
that
okay,
answer.
that is fine. So although yes, if I were the teacher, I would have been given the full marks for this, but I checked the marking scheme, so they have very specifically told to connect the fundamental definition, which is no heat transfer, which is adiabatic.
Okay.
Yes, I got it.
Okay, all right. So do you need some time to note it down, or are you done?
Yeah, copy this down.
Yes, please write this down.
So we just have to write that since it is rapid, there is not enough time for energy
Transfer.
change to take place.
Yes, correct.
But what about the kinetic energy then? That energy is gained, right? Because like based on the answer that I said. So that's also a form of energy which it gains.
Mm, just a minute. Yes, kinetic energy. No, it would.
Isn't it technically then wrong to say that that the short period of time is not sufficient for any energy change?
Okay, so basically, when we say the time is very small and the energy transfer is, this is not zero energy transfer. The energy transfer definitely will take place, but it will be very small according to this description. Okay, but why I
Okay,
got your
but
doubt, so what you are saying is the kinetic energy will also increase.
yeah, like what the explanation that I had given, like the answer that I wrote based on that, the kinetic energy does increase. So like that is also a form of energy, right? Which is contributing to a change in thermal
Okay,
energy.
now I understood why the marking scheme has not given marks for this. So when you say time is very small, it's like saying 0.0001 second. For the kinetic energy to take place, it also needs some sort of time, isn't it?
I didn't get this point.
So let's say if you have, let's say, a molecule and you are hitting it with some other molecule like this, it is coming in, let's say, with a velocity 10 meters per second. This was initially at rest. Now what happens later on, let's say the molecule behind this is 5 meters per second and the molecule in front is, let's say, 5. Now from state 1 to state 2, there will be some sort of time difference between these two. Let's say that will be a microscopic time difference, let's say 0.05 seconds for this energy transfer to take place. Now when we say a rapid transformation, that is even lesser than this, a minuscule time, so 0.0001 second. So this is, in this particular time, the energy transfer is not taking place. Are you getting this?
Yeah, sir.
Or is it not clear still?
No, like I was still thinking that even if the time is too small, that doesn't change the fact that the piston was pushed in with a substantial force, right?
Okay, so let's do one thing. Let me give it a thought. So I'll explain to you in the next class. Is that fine? So I
Okay,
understood
sir.
your doubt. I'll get back to this.
Like how I was thinking of it is since it is rapid and like the volume is being reduced so quickly, then in a very small amount of time, a lot of energy is being produced. So like I was thinking of that. That's why I was not able to understand what you just said.
Okay, so I understood the your thought process. I'll get back to you. But what the solution is referring towards is whenever the t is small, so any sort of transfer needs some sort of time. So if you put time as 0, approximately 0, then they say that the energy transfer is not 0, is 0. Anyways, give me a few days, I'll get back to you for this.
Okay, sir.
I have to think on this. Alright, so question 4 is done. We are left with the last question 5. Okay, this you Ayush, did you solve this?
Yeah.
Can you tell me your answers?
Yeah. So for the first one, I got 4,000
4,000,
for
okay.
for 5-1.
Okay, and Somil, what's your answer?
I got 3980 joules.
3980. Okay, that is also
To be,
fine.
to be exact, I got 3750, but like if I round it off, then it'll be
Alright,
4000.
both of you are correct. So the range which they give marks for is this 3600 to 4100. So if you have got an answer within this range, you will get the full marks according to the marking scheme. But I would want to know the approach. So Somil, tell me, how did you solve this?
So I just found the area that is represented by one small square, and then I counted the small square in the region where there is a curve or when a
Okay,
full box is not being
so
present.
what is the area of one small square?
I got it as 10 joules.
Yes.
One small box is equal to 10
Yes,
joules.
so then all you need to do is find out the number of squares. So if you
Yeah, so
multiply,
I got 398 squares, so I multiplied that by 10, which is
Yeah,
380.
okay, that's
I
fine.
have the same method. Yeah.
Yes, so Ayush, that is also correct. So anyways, in the number of squares counting method, students vary the actual result. That's why the examiner has given a full range. Your answer should lie between this to give you the right marks. So 3980 is fine.
So just to confirm, we had to count the squares between the lines A and C, right?
A and C and B and D, or the whole
Yeah,
thing.
like in the enclosed region.
Yes, in the enclosed region. All right. Part 2. Explain whether the network is done on the gas or by the gas. Ayush, tell me your answer.
So I wrote it's done by the gas as the pressure needed during the compression is lesser as compared to during the expansion.
Mm, Pressure is a variable in expansion and contraction.
Yeah, so like I wrote that the pressure which would be needed during the compression would be lesser as compared
Yes,
to the
correct.
pressure needed during the
That
expansion.
is the exact thing which you have to write, for which they will give you marks. Somil, what was your statement?
So I wrote that since this is like this process is taking place clockwise,
Mm-hmm.
the work done by the gas is much more than the work done on the gas. So
Mm-hmm.
like the area under C is much more than area under A. So
Yes,
that's why the work done is positive and it is done by the gas.
correct. So both of you are right, but let me tell you a few things. So in the marking scheme, a lot of students, what they do is they just write clockwise, since the graph is clockwise, so the work is done by the gas. Although this is right, but they do not give marks for this. So you have to write the basic fundamental thing. The clockwise thing was derived from a fundamental thing, and that is, if I consider the whole thing A, B, C, D, so the total work done will be work done during A, work done during B, WC and WD. So now if I start with the easiest one, so B and D. Ayush, can you tell me what is the work done during the B and D?
So for B and D, the yeah, so
See, I told you, if you consider B, the volume is constant. So the work done formula is P delta V, like I told you. In B and D, the delta V is 0 because the volume is constant, isn't it, Ayush?
yeah, yeah,
So the work
correct.
done in B as well as D will be 0. Now you are left with WA and WC. So A, okay, so WA will be the work done in the process A, and that will be this. If I draw dotted vertical lines, so this particular area region represents the WA. Let's say this value is X, and if I want to find WC, that will be the whole thing. So if I consider the enclosed area, let's say that is Y, and X was the original, so WC will be X plus Y. Ayush, did you understand this
Yeah,
part?
yeah,
Now WA in A process, the volume is getting decreased, so the work done will be negative. So WA has a negative value, whereas WC, in that case the volume is getting increased, so the sign it will have is positive. So then we say, okay, now
Yeah.
the statement which you had written, Ayush, comes from here, that the work done during the expansion, this is greater than the work done during the contraction, because of which the net work done is positive, and hence we say that the work is done by the gas. Is this clear?
Yes, sir.
Samil, any doubts?
No, sir, I had the same approach.
Yes, so but please be careful, if anyone writes just this much clockwise and then you write by, they will not give you the marks. They have, in the marking scheme, it is specifically written. So that's why I said you have to go back to the fundamental things. So the clockwise thing was derived from the fundamental, right? So this is the way to explain. All right. Part 3, deduce using the data that the change C is isothermal. Saumil, tell me, how did you get this?
So I just like I wrote that when the temperature is constant, I mean when it's an isothermal curve, the value of pressure into volume is constant. So I just took three different points on the line C and I proved that the value for pressure into volume is constant, is the same for all three
Perfect,
of them.
absolutely correct.
Yeah.
Ayush,
Yeah.
you did the same?
Yeah. So the value will be 6,000 there in
Perfect,
this
yes,
case.
6000. So the
Yeah,
product
6,000.
PV will be 6000 and that will be constant. That is why this is isothermal. Great. Part 4. Isothermal change A occurs at a temperature of 450. So we have to find the temperature at which the change C occurs. Ayush, can you tell me your answer?
So like for this one, I didn't exactly get it, but I know it's something to do with PV by NR,
Yes,
but
you
I don't
have
know
to
what to
use
put
that.
as N
Okay, that,
because
okay, no
they
problem.
haven't given any molar value.
All right, but that is the trick. You need not need those values. Saumil, did you solve this?
Yes, I got 1350 Kelvin.
Which is correct, 1350. So how did you do it?
So since in the beginning they have mentioned that the mass of the gas is fixed, so the number of moles will also be fixed.
Correct.
So from the graph C, from the graph A, they have given the temperature. So the number of moles is the only variable. So I found the number of moles from there, and then I substituted it with the pressure and volume values from the graph C,
Correct.
and I got it as 1350.
Okay. Anyways, Ayush, let me explain. You have to use the same ideal gas equation. PV is equal to nRT. Now consider the process C. In that, the PV you had found as 6000, isn't it, Ayush?
Yeah.
So on the left hand side, I can write 6000, and nr you can keep as it is, and the temperature. Now that temperature is what you need to find, right? Now it is given that the isothermal change A occurs at a temperature of 450 Kelvin. So this was for C. If I write down the same equation for A, on the right hand side you will get nr into temperature at A, which is 450. Now let's check what is the product of P into V for A. So Ayush, just have a look at the graph and check what could be the value of P into V for the process A.
Yeah. 1 second. Um. Yeah. So you take 75 and 200.
75. Okay, wait. So where is 75?
Oh, sorry, sir. Not 75. You take
So consider a simpler point. So take this extreme right point and find the product into volume, or pressure into volume.
Yeah.
So that will be 200 multiplied by 10, isn't it?
Yeah.
Which
Yeah.
is 2000. So
Yeah.
product of pressure and volume for A is 2000. So now you can see, if I just divide these two expressions, the NR will vanish. So 6000 by 2000 you will get 3, and you will get T divided by 450. So on solving this you will get T as 1350 kelvins.
Okay. So can I just copy this?
Yes, please do.
Done, sir.
Alright, last part. Did you solve the last part, Ayush?
Yeah.
Tell me. You have to describe the changes B and D.
Yeah. So basically, what I wrote was that for B, the thermal energy, for B, the internal energy increases, and for D, the internal energy decreases. Therefore, both will be isocoded.
Uh, let's do one by one in B as well as D. Okay. So you have to describe the changes. Tell me in B what is happening. Is the internal energy increasing or decreasing?
For B, it's increasing there,
And what is the reason?
and for D, it's because the temperature increases there.
Correct. So temperature increases, therefore the internal energy also increases.
Yeah,
And in D,
it's the opposite for D.
correct.
The
So
temperature decreases,
temperature
so I
decreases
decreases.
and the internal energy decreases. Alright, if
Yeah.
I want to know the heat energy Q, is it into the system or outside the system for B and D?
So because internal energy increases, so it should be into the system,
Yes. And for D,
out outside.
yes, outside the system. And
Mm.
let's say
Another
the
way you could also say that the pressure for B increases
correct. And
because the
for
temperature increases.
yes, and for D, pressure decreases.
Decreases because temperature decreases and internal
Wonderful.
energy
So this is
decreases.
the whole explanation which I wanted to know. So Saumil, is this what you wrote?
So I actually didn't go into the internal energy and heat. I wrote that it was an isochoric increase in pressure and temperature. And for D, I wrote isochoric decrease in pressure and temperature.
Okay, that yeah, that is fine, but might as well you can write down the whole comprehensive thing.
So and in this case, the volume won't change, right? Because it's
Yes,
isocoded.
so in B and D, the delta V is 0, isochoric, correct. And because of this, the work done is equal to 0
Yeah.
in both the cases. Alright, so this was
So
the
for B, the change in internal energy is negative because of the decrease in temperature,
yes,
and the
absolutely.
Q, and it is losing heat, right?
Yes. So if I
And
say
for
Q is
B, it is going in.
yeah, so if I write the first of thermodynamics, W is 0 for both. Now for D, your delta U is negative, so which means Q will be negative for D, isn't it? That's when we say that the heat is going outside the system. Is it okay, Samuel?
Yeah, yeah.
Same logic for the process B. Okay, let
Yeah,
me know when you're
so
done.
okay, got it.
Okay, fair
So
enough.
since it is losing internal energy, the change in heat is like it is losing heat, and since internal energy is positive for B, it is gaining heat.
Absolutely perfect. Yes, that's we say the heat in the Q is into the system. Right, so this is the way how we describe these changes. So make sure you have written down all of the parameters. That's how they will give you the marks. describe the changes BNB. All right. So you have, so in the IB you have to make sure that we are writing it comprehensively, because in the marking scheme what they have done is they make sure they read the whole thing, but then they are looking for the key words, the fundamental definitions which they are after. They give you marks only on that. Is this clear?
Yes, sir.
Okay. All right. So this ends the all the non-MCQ parts. Now we can do the rest of the MCQ questions. Now, Samuel, since you have done these questions, so you can stay back for discussion if you want.
Yes, sir. I think I'll stay for 15-20 minutes if we are done by then.
Yes, no problem. Okay, Ayush, what's your answer to 11th?
So for question 11, I wrote C.
Yes, that is correct. How did you do that?
So 1 second, I'll just read this again because it's been a while. Um,
So question 11 of the MCQ.
yeah, so basically the pressure remains constant, and also the uh, so basically the pressure would basically like depend according to the kinetic energy, and if the pressure remains constant,
Mm-hmm.
then that means that equals to the kinetic energy that remains unchanged, and the only way that would happen is if you double the volume as well.
Yes. Okay, so let me read the question. So the kinetic energy is doubled. Now the kinetic energy doubled means the temperature is also doubled, because kinetic energy is directly proportional to the temperature.
Temperature.
So
Yeah.
that's it. You have to use the ideal gas equation. If the pressure is constant and the NR is always also constant, so the temperature is getting doubled, which means the volume will also get doubled. So
Yeah.
2B is the answer, right? Okay.
Mhm.
Next question. So this is a theoretical question. Ayush, what was your answer?
I wrote B.
B or D?
BB. Low
Yes,
pressure, high
low
temperature.
pressure and high temperature. You have to remember this by heart.
Yeah.
This is just a theoretical question.
Yeah.
Question 13th. Yes, what's your answer?
13th, I wrote A, but
No,
I'm not
A
very
is
sure.
not the right answer. So let me explain. Okay, Somil, can you explain this? How did you get the right answer?
Yes, sir. So, sir, since we know that the Kelvin, like if the temperature was in Kelvin, it would have passed through the origin.
Yes,
But here it's not. But since here it is not passing through the origin, we can definitely exclude option A and C.
correct.
And then we just have to figure out on which axis is pressure.
Mm-hmm.
So for like that, what I did was I first imagined the normal P upon T graph.
Mm-hmm.
So in the P upon T graph, the uh, line meets the negative x-axis when the temperature is in Celsius, but here it is meeting the negative y-axis, so it is just flipped,
Okay.
which is T upon T, not P upon T.
Yes, so that is correct. But anyways, Ayush, let me explain. So the general equation of a straight line is y is equal to mx plus c. Now, Ayush, m here stands for the slope, and what do you think c is?
The y-intercept.
Perfect. So in this particular graph, which is visible to you on the screen, what do you think? Is the y-intercept positive or negative?
No, the y-intercept is negative.
Yes, in this case, y-intercept is negative. So this is what you have to use basically to arrive at the answer. So your y-axis is r and x-axis is s. So in the options, the only variables which you have to focus on is pressure and temperature, because these two variables are in all the options. So if I focus on PV is equal to nRT, so if I take R, which is the y-axis, as the pressure, this is your y-axis, and the temperature is your x-axis, so pressure will be basically directly proportional to temperature, isn't it, Ayush?
Yeah.
Now whenever you have this kind of a relation where y is directly proportional to x, this means the graph is a straight line, but it has to pass through the origin.
Yeah. But in this case,
In
it's
this
not.
case it is not, which means the option A is incorrect.
Correct. Yeah.
C is also incorrect
Yeah.
because of the same reasoning. Now we check this B part, pressure versus temperature in degrees Celsius. So we write down the same equation, PV is equal to nRT, but in place of T I write the, let's say, the degrees Celsius value. So what do you think I should keep here, put here?
I'm not sure.
Okay, so let's say if T, small t, is the temperature in degrees Celsius, so we will have to add a 273 to it,
Oh, okay. Okay.
right?
Yeah.
Because
Yeah.
the temperature which we put in the ideal gas equation, that has to be a Kelvin, right? So now
Yeah.
if I, PV is equal to nR into T plus nR into 273. Now pressure is the y-axis, so let me divide the whole expression by volume V. So the left hand side will be P, and here you will have nR divided by V into T plus nR into 273 divided by V. Now if you observe, this is your standard equation, y is equal to mx plus c, where slope is nR by V and the y-intercept is nR into 273 divided by V, isn't it, Ayush?
Yeah.
Now
Yeah.
what you have to observe is this positive sign. In this particular case, the y-intercept is positive, which goes against our earlier deduction that the y-intercept has to be negative,
Okay. Okay.
right? So that's why
Understood.
the option B is incorrect. So
Okay.
option D is right, but anyways, let us check how it is right.
So
So
can I just copy this?
yes.
So could you scroll up a bit? Yeah. Okay. Thank you. So yeah. So I'm done with this part. Could you scroll down? Yeah. Done, sir.
All right, now let me elaborate a bit on the D part, how that is correct. So the temperature in degrees Celsius, that is your y-axis, and pressure is your x-axis. So we focus on the same equation which we wrote here. Now after some rearrangement, I can write nRT, that is equal to PV minus nR into 273. Is this correct, Ayush?
Yeah.
Now since
Yeah.
the temperature is supposed to be the y-axis, so I can divide the whole equation by nR. So if I divide the whole thing by nR, I'll get T in the left hand side, and on the right hand side I'll get P into V by nR minus nR 273 divided by nR. So this will get cancelled out. So now if you see this, we can relate with the standard equation, which is y is equal to mx plus c, where the slope in this case is V by nR and the intercept is
Yeah.
273, but the key is this
273.
negative sign, right?
Yeah.
So,
Understood.
so that's why the option D is correct. So
Okay.
do you want to write this?
Yeah. Just like this. Done, sir.
Alright, so let's move on to the next question. Ayush, tell me your answer to this.
So for 14, I wrote B.
B for Bombay, right?
Yeah.
That's fine. That is correct. So this is self-explanatory, right? Or should I explain?
No, no.
Okay.
I understand. I know.
Question 15. This is also easy. What's your answer?
I wrote A.
Perfect. Temperature remains constant.
Yeah.
16th. What's your answer to this?
16th, I've written as B.
320. Wonderful. That's right. How did you solve this?
So I used P1 V1 upon T1 equals P2 V2 by T2.
Perfect. So
And
using
you
this,
just put all of the values and you find for P2.
fair
So
enough. So 320
P1
plus
V1
this.
T2 upon T1 V2. So
Yes,
P2
yes.
equals B.
That's fine. That's fine. So question 17th. Okay, this is also not difficult. What's your answer?
17 I wrote as B.
B. No, that is incorrect. You have to check this. Samuel, could you explain your answer to this?
Yes, sir. So magnesium has a molar mass of 24 and they have given 12 grams, so that is 0.5 moles.
Yes.
So like the same number of particles another 0.5 moles of substance will have. So out of all of them, only A part, which is 6 grams of carbon 12, that
Yes.
is the only one with zero point 0.5 moles.
Ayush, did you understand? Or should I explain?
Yeah, no, I understood now.
Okay, can you tell me the number of moles in all the options?
Yeah, so the B would be 1 mole,
Okay,
C would be 2 moles,
perfect. And the last?
and D would be again 1 mole.
Perfect. Absolutely, that's correct. So 0.5 moles is only for option A.
Yeah,
So how did you get B as the answer earlier?
so I'm not very sure. I must have not thought of it properly before.
Okay, so now you have understood the logic, right?
Yeah, yeah. This was
Then
an easy
18th.
sum.
Okay, so what's your answer to 18th?
For 18th, I wrote B
Yes, that's correct. And your approach?
because I again used P1 V1 by T1 equals P2 V2 by T2.
Yes,
So 2P half V upon T1. So
correct. So that's
that
fine.
gives.
Also, you can check this is if whenever the product of pressure and volume remains a constant, if this is a constant, that would mean temperature is also constant. So if the pressure is doubled and the volume is halved, so it will not have any change, right? So multiply it by
Yeah,
2 and divide by 2. So
yeah.
which means PV remains constant, hence the temperature remains constant, which is
Mm.
just the original temperature. Question 19th. What's your answer?
19 I wrote A.
Perfect. And the approach?
I'll just read it once. One second. Yeah, so basically they've said that the pressure of the gas increases, right?
Mm-hmm.
And if the pressure increases, that means the kinetic energy would increase. And
Step by
we
step.
know that the
You have to write.
internal energy is
Oh wait. So
the
you have to write it down step by step. Pressure increases. That means temperature increases. So you can
temperature
write.
increases. So we know that internal energy is the sum total of kinetic energy and potential energy. So if kinetic energy gets affected, then even the internal energy would. And because in this case it's increasing, so
Mm-hmm.
even the internal energy would increase.
Yes.
And because it's
What do you
because
think
the
is the
pressure
work
is
done
being,
in this case?
sorry,
What do you think is the work done in this change?
uh, because it's isochoric,
Mm-hmm.
so the work would be zero there
Perfect. Since work done is P delta V and delta V is 0 for an isochoric, so the work done in this case
because
would be
the
0.
volume is remains the same.
Perfect. Yes. Right. So that's why the Q will be positive and hence it is to the gas, into the
Towards the
gas.
gas. Yeah.
Last question. Let's
Yeah,
answer to this.
20 plus C.
Right. Perfect. Just tell me your explanation.
Yeah, just the
Anyway, just a second. Samuel, could you explain this? The answer to this 20th?
Yes, I will. I'll have to read it once it's been
Okay.
2-3 days.
Okay.
yeah. So should I say?
Yes.
Yeah. So basically, they've told us that there's a cube of ice which has been submerged into the water,
Mm-hmm.
but like the key word here is that it's in a thermally insulated container, which means there will be no heat transfer outside to inside. So the inside would be separate to its own. So, and they've mentioned that the temperature for the ice and the water are both zero. So with no heat energy being transferred outside or no heat energy coming inside,
Perfect.
the ice won't melt because there's a constant temperature change.
Wonderful. So that's why the change in temperature is zero and no ice will
Zero,
melt.
yeah. And yeah, so the net amount of ice that melts would be zero
Yes.
because it's the same temperature.
Perfect. So that's why in that previous question, when we were supposed to define thermal energy, it is very important for you to introduce this concept of temperature difference. Right? So in this case,
Yeah,
delta T is zero, hence nothing is going to happen. No ice melts.
yeah,
Saumil, was this your approach?
Yes, sir. Like what I thought was since the energy flow is based on the temperature and not the amount of energy, so that's why since both of them are at the same temperature, there will be no heat transfer.
Mm-hmm.
So if there is no heat transfer, then the ice will remain ice and water will remain water. So none of it
Perfect.
will melt.
Perfect.
And since there's no like transfer of energy, then temperature will also remain constant.
Perfect. That is right.